Let us now understand about the queues. So it is a linear non-primitive data structure, and it is also the ordered list. So QUE Q. And one thing is, it is a linear and non-primitive data structure, and Q is a ordered list. It follows FIFO principle. So what does FIFO means? First in, first out. Let us understand what is first in, first out in just a while. And it has two main functionalities. One is front and other is rear, where front is used to delete elements from queue, whereas rear is used to insert elements to queue. And it is implemented by two ways. Implemented using the arrays, and other is linked list. Arrays means it uses static memory, whereas using the linked list we can have a dynamic memory allocation. Before going to the structure of queue, let's understand the examples, some practical examples and some computer related examples. First one, let's say there is a movie ticket counter. So movie ticket counter is present here, and this is how every person will be standing, right? So person 1, person 2, person 3, person 4, person 5. So there are 5 persons. So if sixth person want to enter, he will be adding from here. So in queue, this is known as a front of queue. This is the rear of queue. So if any new person want to come, he will be coming at rear of queue. So here he will be coming, and at the counter, who will be first leaving this queue is this front person. The person who is at the front side, he will be moving out, because he will be getting the priority access in this queue, because he is the first person who entered into the queue. So this is the same thing. So first in, the person, so this P1 is the person, right? P1, P2, P3, P4, P5, P6. In terms of array, we can say 0, 0, 1, 2, 3, 4, 5. So yeah, so first in, the person who entered into the queue first is this P1. He will be in the front, so he will be the first person who will be out also. So P1 is the person who will be going out of the queue at the earliest rather than all, because he is the first person who entered the queue at the earliest. So this is front, this is rear. So this is always the last element, or the last element or item present in the queue is denoted with rear, and the first element which is present in the queue is denoted by front, similar to like head tail. But here we don't use the concept of like head tail. Unlike in linked list, we in queue use the notation front, rear. And so here also we need to understand one thing. So from the starting, that is from the front, so what is happening? Deletion is happening, because from the front no person can get added, right? No person can get added from the first. Only the deletion or leaving from the queue is possible. So delete, so we can say simply delete at beginning. So this is technically called as a NQ. So it is similar like of pop in stack, similar to like pop in the stack. So this is NQ, and the person who is in the last, so he will be, so the insertion can happen after this person, right? So it means, so insertion happen at the end of the queue. So rear means end, right? So at the end of the queue, insertion will be happening. So okay, just a minute, here it is deletion, right? So deletion means DQ, as it is insertion means it is known as NQ. So NQ is something similar to like push in the stack. So in stack we call push, here we call NQ. So here the terminologies what we have saw is what is front, what is rear, and what is NQ, and what is DQ. So yeah, these are the main things we need to understand. What is first in, what is first out. So these are all the technical things related to the stack, queue. So here one example we saw is the, let's say, counter we saw, and second example in terms of computers what we can say is we can say like this. So let's say there is a printer. So what is printer? It is a shareable resource, multi-shareable resource. So this printer is there, and there are, let's say, different computers, C1, C2, C3, and C4, C5, and etc. So these are the computers which are present. And let's say computer C1 wanted to access it. So it first requested, got connected to printer at the first and requested for printout. And next, so C3 requested, and then let's say C4 requested, and then let's say C2 requested, and then finally C5 has requested. So between all these computers, so C1 will be, so this is the queue now, right? So based upon the request, after C1 completed its task, that is using of printer, then only C3 can access this printing, this printer, and then C4, and then C2, and then C5. So this kind of scheduling can be happening. So the scheduling of task can happen with the help of this queue technique. So these are some. We will later on see what are the various applications related to these queues. The simple logical representation of queue will be of this way. So this is queue logical representation. So there are multiple elements. So the first element is known as the front, and the last element is known as rear. And if we are using arrays, means the linked list will be the array will be of with index this type. And yeah, so this is how the queue representation will be. And here we will be inserting the elements, so like 10, 20, 30, let's say 40, 50. And also we need to understand that only from the front the deletion can happen. So like this it will be. So delete will be from here, and insert from will be from here, right? So delete from the front is known as a DQ, DEQUE. And so DQ function we will be using similar to pop. And inserting at the rear is known as a NQ. It is like push technique in the stack.